Microsoft literally just crammed a GPU inside your standard data warehouse. And I'm not talking about some specialized GPU for AI setup. I mean your everyday SQL queries. The exact same sum, join, and group by statements you've been writing for 10 years are about to execute directly on NVIDIA hardware instead of a CPU. Zero syntax rewrites, no changing your code, it's the exact same query, running on an entirely different piece of silicon. Think about the physics bottleneck that literally forced this architectural shift. CPUs tapped out a long time ago, right? Moore's law stalled, and every trick in the book to squeeze more juice out of x86 is tapped out. But data volumes, they exploded. So the math on your cost per query started trending in a really bad direction. You're processing way more data on the same stagnant hardware, pushing bills higher. Meanwhile, look at the other side of the Azure server rack. It's completely stuffed with massive, expensive NVIDIA AI chips. And here's the crazy part. A lot of the time, they're just sitting there completely idle between inference jobs, just massively powerful silicon twiddling its thumbs right next to a data warehouse that's absolutely choking on its CPU limits. But the real tipping point, the thing that completely broke the traditional warehouse load profile, is agentic workloads. Think about it for a second. A human opens the Power BI dashboard, stares at it for 5 minutes, and closes it. An AI agent doesn't do that. It absolutely spams the exact same complex analytical queries dozens of times a minute, and every single query blocks the next step of its reasoning process. Traditional warehouses were just not built to handle that kind of relentless, continuous hammering. So, enter CoddSpeed. This is the brand new engine Microsoft engineered specifically to solve this exact CPU choking problem. The origins of this are actually pretty fascinating. It started out as a genuinely weird research prototype called TQP, the Tensor Query Processor. The researchers basically asked a wild question. Could you take a standard SQL join and express it as a PyTorch tensor operation? Turns out, yeah, you absolutely can. They successfully mapped standard relational math directly onto tensor operations. It worked. The only problem was, it was completely glued to PyTorch and specific GPU architectures, meaning it couldn't exactly ship as a hardened enterprise product. So to fix that for production, they built two deliberately thin abstraction layers. The first half is the Compute Abstraction Layer, or CAL. This routing layer basically takes your query fragments and fires them off to whatever code processor happens to be available. Right now, that's a GPU, but tomorrow it could be an FPGA or some custom Microsoft silicon. And the beautiful part? It does this completely under the hood. It doesn't mess with the query optimizer at all. Then you've got the second piece, the Data Abstraction Layer, or DAL. This is designed purely for hyper-efficient data movement, and it's completely hardware agnostic. That's the entire design philosophy at play here. Build an execution engine that moves data seamlessly, ensuring the architecture outlives any single generation of chips. Oh, and they named it CoddSpeed after Edgar Codd, the pioneer who invented the relational model way back in 1970. That alone should tell you exactly how Microsoft is framing this release. They are treating this as the biggest, most fundamental shift in query execution since 1970. All right, let's talk numbers. Microsoft's internal testing kicks off with claims of a 3x speedup for a single user hitting the warehouse. Then that escalates to 6x faster when you scale up to 16 concurrent users. And then they claim it hits 7x faster at 64 concurrent users. Notice the pattern happening there? The performance advantage grows aggressively as more people hammer the system at once. That's because under heavy load, CPU thread pools start fighting each other for cache space and memory bandwidth. GPUs just do not have that problem in the same way. Their architecture scales vastly better under massive concurrency. Now, I want to be entirely straight with you about these numbers. Notice what they didn't say. 3 unnamed competitors, an undisclosed benchmark suite. Look, this is a vendor announcement, plain and simple. It is not a peer-reviewed, independent benchmark, so I highly suggest you treat these internal multipliers with a heavy dose of skepticism. The one metric I actually trust in all of this noise is the customer data. UNC Health, which is a massive real-world hospital system, reported up to 5x faster query times on their existing production workload. That's not a synthetic test. That's not a polished stage demo. That's their actual, messy, real-world production queries running faster. So what does this actually look like for you hands-on when this hits early access preview in July 2026? Basically nothing. And honestly, that is the whole point. Your T-SQL does not change. Your data stays exactly where it is. The optimizer makes the call on what operations are actually worth sending to the GPU. And if an operation isn't supported yet, it just quietly falls back to the CPU automatically. You literally just flip it on with a workspace toggle. You need to set your expectations appropriately, though. who is actually going to feel this change? Well, if you're running massive Power BI deployments with a ton of simultaneous viewers, think finance dashboards or global ops centers, or if you have those relentless AI agentic workloads we talked about, you're going to see massive gains. But if your workload is mostly thousands of tiny single-row lookup queries, you'll see something, sure, but you are absolutely not getting anywhere near those headline 7x speed numbers. Looking at the competitive landscape, this completely shifts the board. Snowflake has nothing like this right now. They are strictly CPU-based, full stop. Databricks has Photon, which is genuinely an incredible engine, but it's CPU vectorized, not native GPU. So right now, Microsoft Fabric is the only fully managed cloud warehouse executing queries natively on GPU silicon. That gap won't stay open forever, obviously, but that is a multi-year head start, not a multi-month one. But there is one massive, glaring missing variable here that nobody can give a straight answer on yet: the price. A 7x faster query that costs 4x more per compute second might not actually save you a single dime at the end of the month, so please do not make a sweeping architecture call based solely on silicon speed benchmarks until we actually see the final pricing model. Now, everything I just walked you through is maybe a third of what's actually documented. I didn't even get into the full Cal and DAL architecture diagrams, the complete concurrency benchmark tables broken out by workload type, the workspace by workspace early access signup steps, or the full side-by-side comparison matrix against Snowflake, Databricks, BigQuery, and Redshift with every single column compared. That entire breakdown, plus the sourced Microsoft blog links and the original TQP research paper itself, is sitting right now in the written guide linked in the description and pinned comment. If you're actually going to touch the early access preview, read that before you flip the toggle.